14th, 4/14, 23. Pretty exciting. It's not snowing yet, but I think it's supposed to snow at least a little bit, maybe an inch or something like that. So we're not learning anything new today at all. What we're going to do today is first a snapshot, and then we're going to work on our delta maths. But the snapshot, you're going to be asked to do 6 problems. The first 2 you have to do by factoring. The second 2 you have to do by the quadratic formula. And the last 2 you have to do by using square roots. And so you can't just pick the method that you want, like whichever one you like best. That's not going to fly. The purpose of this snapshot will be to see that you know how to do all 3 methods that I've shown you so far. The method that we will not be using is plugging them into Desmos and then letting Desmos graph them for us. So I'm going to go ahead and pause this real quick while I address the situation. So I'm just going to do one example of each. It should take no more than 7 or 8 minutes. I just want to refresh your memory on what the different methods look like. So first off, you're going to be asked to do 2 problems. Again, specifically, you must use factoring. And so for an example of factoring, I mean, they get harder than this, but again, this is just a real sort of basic look at what I'm expecting of you. So remember that factoring is, let's try to come up with something good here. Let's see. Something like this. Oops, that's supposed to be a 50. Apologies, that's not a 10. Ding dong. That's a 50. My bad. So factoring, remember, is not an ABC thing. Factoring is where we set it equal to 0, first of all, right? Which one of them I think, yep, one is and one is not. So if it's not set equal to 0, that's going to be your first job, is make sure that it equals 0. And then remember that with factoring, we're just doing the reverse multiplication, right? So what would I put at the beginnings of my factors? I need an X and I need an X. And without hesitation, what would my signs be? They have to be one of each, because whatever they are, they're going to multiply to make negative 50. So we know for sure that one of them will be a plus sign and one of them will be a minus sign, right? And then at this point with factoring, remember, it's just a matter of experimentation. You can watch 50 different YouTube videos from 50 different math people around the world, and you might find 10 or 15 different methods that people use to factor. But at the end of the day, it still at some level comes down to guessing and checking. So I just always have taught it with the old, let's just get in there and roll up our sleeves and do it. So we're looking for numbers that multiply to make 50. And what 2 probably come to mind pretty quickly. Yeah, and 5 and 10 by this point in our year should feel right to you, because not only do they multiply to make 50, but if I put a positive 10 and a negative 5, yes, I've made negative 50, but more importantly, these 2 in the middle, remember, make 10x, and then these 2 on the outside make minus 5x. And the goal here is always to check and make sure that that blue thing plus that green thing equals this red thing, right? That's just factoring in a nutshell, right? And we've been down this road. You've done worksheets and assignments over this. So those factors work well. And so what would my solutions be, my answers? What does this give me? X. It would be negative 10, because remember, the numbers that solve the equation are the numbers that make our factors. The factors are the things in parentheses. If you can make a factor equal 0, then you've solved the equation, right? It's been a while. So what answer or solution makes the second parentheses equal 0? Positive 5. So I hope that is ringing some bells for you. It's been a while. It's been a minute, as they say. And by that, probably a couple of weeks, actually, since we've done any factoring. But that's what you're going to be doing on problems 1 and 2. There's one that's super easy and one that's harder, right? But remember that factoring can take some experimentation. And you can expect sometimes with factoring that you might try combinations of numbers that don't work. When your blue and green don't add to make red, that's okay. You don't beat yourself up. You just turn your pencil around and you erase and you try a different combination of numbers, different order, whatever you want to do. But eventually it will work. Good there? Okay. The second method that you're going to have to use, again, I'm not interested in you picking your favorite method and using it all 6 times. For these next 2 problems, you have to use the quadratic formula. And somewhere deep in your notebook, you have the quadratic formula. Can anyone right now, just top of your head, recite it back to me? You don't have to sing it or anything. Minus 4ac, all divided by 2a. Very good. And it's just a thing, like the thing with formulas in math is they're really, at this point in our education, like we're not ready yet to talk about where that comes from. This is just a formula that you take at face value and say, I'm going to put numbers in place of letters and work it out. It's not a real heavy do you or don't you get it sort of thing. It's just a can you follow directions kind of thing. So for an example of that, let's say we had like 3x squared minus 4x minus 2 equals 0. And again, like we said, the first step will always be to set it equal to 0. And neither of these on the snapshot is set equal to 0. So what you would actually see, just for the record, might be something like this. And so if the problem that I give you looks more like this, then you understand that we're not ready to consider A, B, and C, right? We're not to that point. So we would focus on not left, not right. It's all relative to, it doesn't matter left, right. What matters is I want that term to be positive. The quadratic formula will work even if he's negative. It's just a little bit more confusing at the end because you get a negative denominator. So my take as your teacher is always make that x squared term positive. Just do it. And so like in this case, I look at the 3x squared and the minus 2, and I say, you guys stay. 4x, I'm going to bring you over, and I'm going to tuck you right in that little gap right there. It's not arbitrary. We want them in that standard form, x squared, then x, then number. So what would my quadratic now actually say? I mean, it's what you wrote down the first time, right? So 3x squared minus 4x. There you go. So I just wanted to show you, be prepared to do that a few times today, that you've got to prep it by getting everything onto one side. And now we can do the quadratic formula stuff where we consider A, B, and C. So what would A be in this particular case? Good. And what's B? Good. And what's C? Nice. You guys are awesome. So once we know those three values, and I'm telling you, you should write them down, something about just pulling them out. I know you can see them if you don't. There's something about pulling them out. It helps. And so it's time to write our quadratic formula. So we're going to say x equals, and here we go. What do we put first? 4. Yes, the opposite of b. Plus or minus a big long square root. Good job, Zane. And yes, b squared is definitely positive 16. Remember, that number that I just wrote will always be positive because you're squaring something to get it right. So even if you use a calculator and you forget to type it in correctly, you know it's still got to be a positive number. Don't ever mess that up. And then I like to put minus 4, and I don't actually put numbers in. You'll remember this about me. I just put empty spaces. And then I come back later. Good job, Bryce. And then I divide by 2 times a, which is in this case 6. And then when I go back into my formula, I need to replace my a and my c with nice. And so the question that I've asked you before when we were doing this a week and a half ago, my first question has always been and always will be, you must study that sign with the yellow arrow. Is he destined to stay a minus, or is he destined to switch to plus? He's going to switch to plus because he's going to encounter a negative somewhere along the line. So I like to get all that out of the way and just put that out of my mind and just say there's no more negatives as far as I'm concerned. I want my brain to see this now as 16 plus 4 times 3 times 2. Get rid of the negatives. That should be an important step for you at that point. It's just assess, is it plus or is it minus? Plain and simple. Now we got to do a little bit of kitty math here, a little kitty math. You don't need a calculator for this part. What's 4 times 3 times 2? Times 2? 24. So what the yellow stuff actually equals up there is 16 plus 24, which is what? 40. So my new and improved version of my answer is 4 plus or minus the square root of 40 all over 6. And this is the part where there's 3 things that can happen. Thing one is that's a dead root. If it's a dead root, you put a box around it, exactly what I have, and you say, that is my final answer. Here you go. Good, sir. Take it. It's yours. Option two is that number in the square root sign might just be a square rootable number, like 36 or 49 or 100. And if that happens, then the square root goes away and we trace the plus pathway and the minus pathway to get our different answers. Option three is this option where it's not a dead root, but it's not a perfect square root. What do? You simplify the square root. Yes, because they're saying great things today. So I take a moment off to the side and I go write down the square root that I'm interested in, 40. And there are multiple ways to make 40. I think there are 3 of them. If you don't count 1 times 40, there are 3 other ways. There's 220, which is trash. There's 8 and 5, trash. Who's the non-trash? 4 and 10. So I'm going to write down, remember my branch, root, and I'm going to put a 4 and a 10. And what is the square root of 4? 2. So what I do now is I take that square root of 40 over there and I swap him out with his simplified version of himself, which means that my answer now, not done yet, is x equals 4 plus or minus 2 root 10 over 6. And do you remember the little Dorito thing that we drew, right? It's kind of just a visual representation of simplification. Just the triangle seems to stick with people's brains. So can all 3 of those numbers be divided? Yes. By 2. 2 is pretty popular. It's not always going to be 2. It might be nothing. It might be 3. It could be 5. I don't know. But in this case, we divide them all by 2. And so this 4, I'm going to cross him out, becomes a 2. This 2 becomes a 1. And this 6 becomes a 3. Do we need that 1? No. Not this time. The only time you'd ever need the 1 is if he was where that 4 used to be, because he's a placeholder. But 1s in front of roots and 1s in denominators are literally pointless. And so we don't put them. So my final answer in a case like this would be x equals 2 plus or minus the square root of 10 all over 3. And that's what you would box up and present to the world. What's one of the answers that I have in this blue box? Read me one answer. Yeah, and I know you meant to say 2. So good. So 2 plus the square root of 10 over 3 is an answer. What's the other answer? 2 minus the square root of 10 over 3. So don't ever forget that that plus or minus sign isn't just this thing. It's just our way of expressing that there are multiple answers. We package them together. Still good? All right. And then for the last section, you are required to use square roots. And square roots, they look a lot. This is what you're working on in Delta Math right now. So this will probably be, I don't maybe not. Could be the roughest section since we're still kind of in the midst of it. But you might see something like this. I'm trying to send you out of this school year with feeling empowered to know all the different methods for solving quadratics, but more importantly, when is each one appropriate? Like this is not appropriate for the quadratic formula because it's going to wind up being more work than it's worth. And it's certainly not appropriate for factoring. So having said that, what's step 1? Divide by 4. Remember, we're in the mindset now of get the square by itself. And the thing I'm putting in this yellow box is called the square. Anything with that is squared is called by definition a square. And that's a square. So I'm going to divide by 4, like Bryce said, and I'm going to wind up with the quantity of 2 minus 3x squared equals what? Yes. And you're comfortable with the fact that that's not the kind of thing we want to actually divide, right? You hung around with me long enough this year to know that there's nothing wrong with 81/4. We love 81/4. Now what do? Square root it, square root both sides, right? So if I apply a square root to the left side, I'm just left with, well, 2 minus 3x. Parentheses are no longer required because the thing that said, I need you here, the squared, is gone. If he's gone, the parentheses are gone. And what does that equal?
Positive, negative.
Yes. Good, which I'm going to go ahead and take initiative on this and just write 9/2. Remember that when you square root a fraction, you just square root the top and the bottom independent of each other. What do we do after this? You subtract the 2 first, right? Remember, the dividing by the -3 would be premature at this point. That should always kind of be your last thought process. So step 1 is eliminate this straggler term over here. So we have to subtract 2 from both sides. So our next line is going to be -3x equals -2 plus or minus 9/2. Everybody still good? Okay. Next step. You guys are amazing. Make the denominators the same, because I cannot, fractions and whole numbers just don't like each other. They can be friends, but we need to make it so that that relationship can happen. And we do that by turning whole numbers into fractions so that they can play nice together. So I'm going to go off to the side here and say -2. I need you to be a fraction that has 2 as your bottom. What would he be? -4. Very good. So it's almost like we take a little break from actually solving the equation there while we do a little bit of 5th grade math, just converting denominators. So we turn this into -4/2 plus or minus 9/2. Next step. Yeah, good. So we basically just take the right side over here and we just make it into one thing. That's what our goal is, just make a fraction out of that. That was why we made the denominators the same in the first place, right? So now we have -3x equals -4 plus or minus 9 all over 2. Conjoin them into one thing, one unit. And then there are a couple steps left. These problems are a pain. What's the next step? Right. And what does it really mean in a case like this to divide? It really means to multiply the bottom, right? And that's something good you can take away from me this year is dividing a fraction by a whole number just means to multiply the bottom of the fraction by the whole number. So our answer, not done, but it's kind of like a final answer, is -4 plus or minus 9 all divided by -6. Now, remember that these are called rational solutions. As soon as the square root goes away, which it did like a minute and a half ago, then they become rational versus irrational. And so now we just do the math. And this is what a shame to get this far and botch it here. Like we can't let this happen. So trace the plus. What is -4 plus 9? It's +5 over -6, which cannot be reduced. It can be expressed as -5/6, right? If either your top or bottom is negative, all math people would tell you, just pluck that negative out and stick it on there. Don't give it to the top, don't give it to the bottom, just put it out front. And then we got to trace the other path, which is minus. What's -4 minus 9? -13, which if we put it over -6 equals, and that's what those answers might look like, right? And I don't want to cover every possible scenario because I don't want this to be a day of me talking. I've already talked 7-8 minutes longer than I wanted to. So I'm going to hand out the snapshot. I want you to get that done first. And then anytime you have left over, I want you to get back to cranking on those delta math number 28 and 29. Got it? All right.